Welcome to this explainer. Today, we're diving into an absolutely mind-bending concept from Einstein's physics that suggests, mathematically speaking anyway, you might just be able to peek into tomorrow. Sounds like science fiction, right? Well, it turns out the geometry of space and time holds some pretty incredible secrets that completely flip our everyday understanding of reality on its head.
So let's just jump right in. We're starting with a totally outrageous premise. According to the higher levels of relativity, seeing the future of distant galaxies might actually be mathematically possible. And no, we're not talking about crystal balls or fortune tellers here. We're talking about the literal, fundamental fabric of the universe. To wrap our heads around how this works, we need to set up a slightly bizarre but super helpful hypothetical scenario.
Picture this. You force your friend to go outside and just run around in the scorching heat. You're literally out there yelling, "Run, brother, run! Run, milk her, run!" just to get them moving. Now, while it might seem like you're just putting your friend through a miserable, sweaty cardio session in the sun, you're actually kicking off a cosmic science experiment. Because believe it or not, the simple act of them physically moving while you stand completely still, that's the exact trigger we need to start messing with the fabric of time.
Section 1. Einstein and the future.
Okay, let's break down exactly how your friend's sweaty jog connects to Einstein's theories of space and time. You see, according to relativity, time isn't just some universal ticking clock that we all agree on. Because light takes time to hit our eyes, your state of motion actually tilts your perspective of now. Think of your present moment like a flat slice cutting straight across the entire universe. If you're standing perfectly still, that slice is totally level. But the second you start moving, or your friend starts jogging, that plane of simultaneity actually tilts. So events that happen at the exact same time for you, standing still, are suddenly completely out of sync for your moving friend.
Section 2. The Andromeda Paradox.
And that brings us to the core of our mystery, a famous theoretical problem known as the Andromeda Paradox. This theory proposes that because time perception shifts based on distance and speed, a tiny bit of motion here on Earth creates a massive sweeping time distortion when you look at something incredibly far away. Remember that tilt in the slice of time we just talked about? Well, a slight shift in your walking speed acts like a fulcrum. Close by, the tilt is microscopic and barely noticeable. But stretch that tilted slice across millions of light years, the outer edge of that slice suddenly sweeps across entire centuries.
So let's bring it back to our running friend. Because that slight motion creates such a massive time difference over a fast distance, your friend could theoretically look toward the Andromeda Galaxy, and their now has shifted so far into the future that they see aliens plotting their next moves. I mean, they might be discussing global warming, complaining about the terrible heat wave in Pune, and deciding whether to prep their sunscreen for an Earth invasion or just cancel the whole trip. It's a hilarious mental image for sure, but the math of physics actually backs up this massive shift in timelines.
It's crazy, but Einstein's equations basically guarantee that your jogging friend has shifted time enough to fast-forward the cosmic tape. They can theoretically see the future plans of those distant extraterrestrials. Because their slice of now tilted so dramatically across the vastness of space, their present is quite literally our future. Just by breaking a sweat, they've conceptually leaped forward in the alien timeline.
Section 3. The speed of light. All right, but before we sound the global alarm for an alien invasion equipped with SPF 50, we need to grab a telescope and face a harsh physical reality check. Imagine handing your moving friend a telescope right at that exact moment. What do they actually see through the lens right now? Well, nothing. Or at least, nothing of the future. If you physically look through a lens at Andromeda expecting to catch those aliens packing their bags, you won't see their future plans at all. So if the theory says the timeline shifted, why on earth can't we see it?
Well, this is exactly why it's a paradox. You see, the Andromeda Paradox was designed to show us that the concept of today or now is totally subjective across the universe. It brilliantly proves that a single, universal present just doesn't exist. But, and this is a big but, it does not mean we can literally spy on tomorrow with a telescope. The mathematical reality of time shifting is absolutely genuine, but the physical act of actually observing it, that's completely blocked.
And the ultimate cosmic roadblock here comes down to one number, 2.5 million. The Andromeda Galaxy is roughly 2.5 million light-years away from Earth. That unimaginably vast distance is the key to unraveling this whole paradox.
Because light takes an incredibly long time to travel across the vast emptiness of space, any image you see through that telescope is ancient. Light from Andromeda takes 2.5 million years just to reach your eyeball. So you aren't seeing the aliens' future, you're actually seeing what happened 2.5 million years ago in their deep past. You have absolutely no idea if their invasion plan even exists yet, because the visual evidence of it won't arrive here for millions of years.
Think about it. The only way you could actually see the aliens' future right now is if light traveled instantly. Meaning, if light speed was infinite and it could jump from Andromeda to Earth in 0 seconds. But if that were true, all of Einstein's proven theories, basically all of modern physics, would just completely fall apart. We live in a universe with a strict, limited speed of light. So while your friend's motion does shift the mathematical now, the physical speed limit of light ensures you only ever see the deep past when you look up at the stars.
Section 4. Is the future predefined?
So, what does this all mean? If the speed of light actively stops us from seeing tomorrow, what does this whole paradox actually teach us about our destiny? This is where the physics gets deeply philosophical. The theory suggests that while the future might already exist on a mathematical timeline, like the events are already laid out on the fabric of space-time just waiting for us to experience them, the physical speed limits of the universe actively keep that future hidden from us. You literally cannot peek ahead no matter how fast you jog.
And honestly, by intentionally hiding the future behind the unbreakable speed of light, the universe actually provides us with something kind of beautiful. These physical limitations give us the hope and the free will to believe we can still change our destiny. Think about it. If we could see the future perfectly, we'd be completely trapped by it. Because we can't, we remain entirely free to shape it.
Which leaves us with this final, burning thought. Knowing that the strict, unyielding laws of physics keep tomorrow a total mystery to us, the only question left is what you will do to shape it today. If the universe actively protects the mystery of what happens next, how are you going to use your present moment? Thanks for joining me for this explainer, and keep questioning the universe around you.